Algebra 1, Lesson 21, Linear Inequalities. Let's start talking about the concept of inequalities. An inequality is a mathematical statement that shows that one expression is greater or lesser than the other. Here are the important notations we need to know when solving inequalities. The less than sign means that the expression that comes before the sign is less than the expression that comes after it. The greater than sign means that the expression that comes before the sign is greater than the expression that comes after it. The less than or equal to sign means that the expression that comes before the sign is less than or equal to the expression that comes after it. The greater than or equal to sign means that the expression that comes before the sign is greater than or equal to the expression that comes after it. Inequalities are for the most part solved using the same rules we use to solve equations, with a few exceptions. We can understand inequalities by sketching them on a number line. Here are a few examples. Let's talk about how to solve linear inequalities. Solving linear inequalities is just like solving equations, except with a few more rules. The most obvious difference is that instead of using an equal sign, we use one of the inequality signs. For example, we would solve the inequality x plus 9 is less than 13, the same as the equation x plus 9 is equal to 13. Using addition and subtraction to solve inequalities is the same as using them to solve equations. So just pretend the inequality symbol is an equal sign, and it's business as usual. So the solution for the original inequality is x is less than 4. The sign doesn't change in this instance, but they do in other instances, and we'll get to those ones soon. Now, with addition and subtraction, the sign doesn't change, but they do in other instances, like with multiplication and division. That is because we can't keep the sign the same because of logical reasons. For example, 9 is greater than 6. If you multiply both sides by -4 and keep the sign the same, you'll get -4 times 9 is greater than -4 times 6, which you can evaluate as -36 is greater than -24. If you know anything about the number line, or just counting negative numbers in general, you'll know that this isn't true, and you will need to flip the sign the other way. So here are a couple of rules you need to know when trying to solve inequalities by multiplying and dividing. 1. You will not have to change the sign when multiplying or dividing each side of the inequality sign by a positive number. 2. You will have to change the sign when multiplying or dividing each side of the inequality sign by a negative number. Let's do a couple examples of solving linear inequalities. Example 1. Solve the linear inequality x minus 6 is greater than 10. This is one of those linear inequalities that you can solve like an equation. So, you easily add 6 to both sides of the inequality, and end up with x is greater than 16. Example 2. Solve the linear inequality -1/5 x plus 9 is less than 19. This is an inequality that will take 2 steps to solve. The first step is to subtract 9 from both sides. On the second step, we need to be careful. We need to multiply both sides by -5 to get the x by itself on the left side. Since we are multiplying both sides by a negative number, we need to remember to flip the sign in our final answer. With that said, the solution for this inequality is x is greater than -50. Linear inequalities could be used to solve a variety of real-world problems as well. We apply the same rules of setup that we learned in the algebraic word problems lesson. Let's get into a good example. A store sells bags of rice for $10 each, and bags of beans for $8 each. The store wants to make at least $400 in sales per day. Write a linear inequality that represents this situation, and find the minimum number of bags of rice and beans the store needs to sell to meet this goal. So, to tackle this problem, we need to get used to the idea that a lot of linear inequality word problems require a standard form setup. In this case, we have two variables we need to find: the minimum number of bags of rice and the minimum number of bags of beans. Our constant is the $400 minimum we need to make. So, our setup inequality is 10x plus 8y is greater than or equal to 400. Quick side note: when a word problem says, at least, you need to use the greater than or equal to symbol. If it says, at most, then use the lesser than or equal symbol. We have our setup inequality, 10x plus 8y is greater than or equal to 400. An easy way to solve this inequality is to split up the constant and solve for both x and y. So we split up the $400 into $200, and we write two new equations. 10x is greater than or equal to 200, and 8y is greater than or equal to 200. These are simple one-step equations, so you should already know what you need to do. Now, our solutions are x is greater than or equal to 20, and y is greater than or equal to 25. We aren't done yet, though. We need to answer what the word problem asked us. What is the minimum amount of rice and beans we need to sell to make at least $400? If we plug in those x and y solutions into our first setup inequality, we'll end up with $400 greater than or equal to $400, which is a logically true statement. We can now answer the word problem in plain English, or whatever language this could be translated to in the future. The minimum number of bags of rice we need to sell is 20, and the minimum number of bags of beans we need to sell is 25. Solving linear inequalities is very similar to solving linear equations. Some of them may take one step or may take multiple steps, but the rules of operations and balancing both sides stay the same. The only difference is knowing when to change the signs if there is multiplication or division on both sides by a negative number. In any case, if you find your final solution isn't logical when you test the inequality, then you'll probably need to flip the sign. See you in the next lesson.